Okay. So good afternoon. Welcome to our tutorial, Building Python Data Applications with Blaze and Bokeh. My name is Doig. I'm a data scientist at Continuum Analytics. And my presenter, Andy Terrel, also from Continuum Analytics. There's also a bunch of people from Continuum Analytics in the room, so raise your hand. Okay, so they can also provide some help if you have any difficulties with the tutorial, I'm sure. First of all, I'm going to introduce how this tutorial is going to be divided. First of all, I'm going to just do like a brief introduction of it. Then we're going to go for the first section, go into Blaze and what Blaze is. The second section is going to be introduction to Bokeh. And the third one is going to put both things together, Blaze and Bokeh, to build applications. To follow along, you've seen that we have the instructions in the GitHub repository. This is a short link for it. You can go there. There you have the README file with all the instructions. Hopefully, you've all been able to download and make all the install. If you still have any trouble, just raise your hand and someone will come and help you out. If you don't want to follow with downloading the repository, you can still do it with viewing the notebooks on NB Viewer. And here's the link. So you can see all the notebooks already rendered and follow along if you don't want to install anything in your laptop. So let's start with what Blaze is. Blaze is this general interface that allows you to query data living in a diverse set of backends. SQL databases, HDF5, Spark, and MongoDB. So it provides a simple querying interface that so you can just like learn one syntax and query all those databases. So it provides that abstraction for you. So instead of like learning all these different systems, applications, queries, mechanisms, you learn one. You can find more about Blaze on this URL and the documentation. And see that Blaze also provides like more broader ecosystem with a lot of different smaller projects like Dask Array and Dyn that are out of the scope of this tutorial today, but are also very interesting. And there's a lot of good material done by Matt Rockling in his blog and doing a lot of good examples of how to use them. But for the focus of this tutorial, we're mainly going to present Blaze Core and Odo. The second section of the tutorial is going to be devoted to Bokeh. And Bokeh is this Python interactive visualization library. How many people here have already heard of Bokeh? Okay, like 50% maybe. So here's the link to the URL. And you can find all the tutorials and the user guide, documentation, and see a bunch of examples in the gallery, the code, and the end result of the visualization. Andy is going to go over more the details of Bokeh in his section. So what are the goals of this tutorial? We want to learn how to query different backends with Blaze, how to learn the syntax and seeing how easy it is and what actually Blaze is doing to make those computations. Then we're also going to learn how we can use the Bokeh library and do visualizations with it. And then putting those two things together to build data applications in a Flask app and see how these two things combined can be very powerful on building this kind of applications. So just like one more time for the people that came in last, here are the installation instructions. This is the last time to like say if you have any problems with the installation. Raise your hand if you do. Okay? Okay. Can someone go help them? Anyone else? 1, 2, 3? Okay. Yeah.
How does the Python become in the new
So the question was, how does IPython become the new Jupyter, you mean? So it's just the IPython 3 version. And they're renaming it to Jupyter to make this like interface that can actually not just use IPython. So to generalize, it can also use R and Julia. And because it can already do that, they're renaming and doing some refactoring of the project. And so Jupyter is just trying to generalize because IPython still, even if it could do R and Julia, it just felt like it was Python focused, and because of that, they've changed it. But you run it the same way, doing IPython notebook, and then generates the Jupyter. Yeah, there are. Yeah, I think Andy just tweeted out like how to get the R kernel, and there's like another expression to get the Julia kernel. But for today, we're just going to worry with the IPython kernel. Okay? Any other questions? Okay. So as we said, there's also this like the static notebooks that you can follow along, the Zero, the Blaze, and the Bokeh tutorial. So this is the GitHub repository, Continuum.io, PyData apps. And so if you download the repository, you're going to find the following. You're going to find 4 different notebooks, the introduction, the Blaze. Then I also have the Blaze solution with some of the solutions of the exercises proposed. Then the Bokeh notebook. The environment YAML file, which contains the dependencies that were used to create the environment. The Iris CSV dataset, an SQLite with baseball statistics. And these other 2 are ones that are going to be created when we go through the tutorial. And then we're going to have a folder with embedded apps that's going to contain some of the apps that we're going to see. And just like some images that are used there.
Environments file, the versions are not specified.
Yeah.
So does it mean that if I'm going to rerun the same command half a year from now, I'll actually have the
right.
version?
Yeah, that's a good question. So right now we just use like the latest versions of everything, but there's a conda-env command that's conda-env export that allows you to export all the versions that are installed in that environment. So if you do a conda-env export, you're going to get a freeze of that exact environment, so you can always reproduce it a year from now, this exact. So, any other questions? Okay. So let's start with the Blaze introduction. So as we've said, in this tutorial for Blaze, we're going to learn how we're going to discover what's on our data sets, how we can easily migrate from different data formats, different databases, how we can query the data with the Blaze expressions. And so, as I said, inside the Blaze ecosystem, we're going to focus this tutorial into 2 packages. Auto, that's allowed to move data from different databases, different formats, and Blaze, which is like the query syntax. This is like the installation if you've not followed the previous one. So what's the goal? Why was Blaze created in the first place? So Blaze comes with a PyData ecosystem, and as how many of you have heard of already from NumPy pandas? Probably most like everyone, right? So why do people like NumPy pandas? Why do you like NumPy pandas? Or do you don't like NumPy pandas? People like it because it provides you like a very accessible way to querying your data set, very interactive, a very simple syntax, very useful, right? So we can see something like very simple. We have this Iris data set. We do a head, and we can explore what's in that data set. And we can do like more queries and like pandas. I don't know if you've been in the previous tutorial. That was like I had a big section on pandas. All the different things you can do with pandas, filter, group by, whatever. So that's great. But what are some of the problems of pandas and NumPy? What's the problem? Local? Local machine, that's a good point. What else? Yeah? Anyone else? What other problems? Memory, right? Like, it's great, but when you start having larger data sets, that doesn't work well anymore, right? Like, you run out of memory. So what do people do when they run out of memory? They put those data sets into databases, right? Or in local disk. So then you lose all these like syntactic sugar or easily querying those data sets, and you have to start learning all these different systems, right? All these different querying languages, SQL and all the different varieties depending on the system, SQLite, Postgres, all the different distinct things. MongoDB, Spark. Every month there's a new, right? A new good library to use, and you have to learn, how to use it. Or there's people building libraries on top of them, wrappers, to interface them. So Blaze comes from the idea, or has the goal of how do we provide the same interfaces, pandas-like interfaces, to all those different types of backends. So a lot of people ask this question, like, well, why would I use Blaze instead of pandas? And that's not really the question, right? Pandas is more focused on when you have these two cases. You have a large, inconvenient amount of data that you're not able to use pandas or NumPy anymore, or the data lives somewhere else, like not in your local computer. That's the two issues that you've raised, right? So let's explore what kinds of databases are there and how they relate in the Python world. So that's what we said. When we go out of memory, we go into database, and we have all of this. Like we have SQL, and we have libraries in Python that allow us to interface with those systems. SQL Alchemy, and all Hive and Cassandra with PyHive, Impala. We have like document stores like MongoDB, HBase, Spark, and then all these systems to talk to like remote data, like SSH with Parmico and Bodo. And then we want also another thing that Blaze and this Blaze ecosystem provides is Odo, which is an easy way to move data around all these different systems to be able to put the data where it's more appropriate for the use case you need and for the type of analytics and query you want to perform. So first, let's go explore a little bit more about Odo. And maybe we just had a rebranding of the package. It was formerly known as Into, but it was very hard to find it. And so we renamed it. Rename it to Odo. So that's what we said. It provides a very simple interface to move data around. And it's as simple as this: Odo from the source, where it's located, to where you target, where you want to put it. That's it. That's Odo interface. That's all it does. So we can see examples. I want a CSV into a pandas data frame. Well, Odo from the CSV to a pandas data frame. Do I want to put it in do I need a JSON file? Then this data frame into a JSON file. Do I need from the CSV to a JSON file, the Odo CSV JSON? So let's have like a small exercise just to get like a little bit, a little practice, a little bit of our fingers moving. And just like very simple, just try and put turn this iris CSV into a Python list, a NumPy array, and a pandas data frame. There's like one example of the 3, so you just have to do 2. I want to hear some fingers. So just like 1 minute or 2 minutes, like 2 lines of code. Come on. I'm not hearing anyone. Anyone has anyone have like installation problems, not able to run the notebooks? Yeah? Okay. Who can help? Raise your hand if you do. Can someone, Andy, Aaron, can you? Come on, 2 minutes, people. Just type, even if it's not the exercise, just so I think you're doing something. S3? Yeah, we'll see that. Let's because it has like a specific way syntax of saying how to go to S3 with the URI, how you spell it, but that's the next section. So. Yeah, well, if you have like, you're gonna need access to like that bucket, right? So we're gonna see the reverse, like from S3 to like a public S3 to your local. Okay. Any other questions while other people finish typing 2 lines of code? Yeah. Yeah, the one that's below, yeah, that's a public repository, like a S3 bucket. Reading it? Okay. You need to, yeah, install Bodo, con install, you have? Yeah.
Yeah, there's a warning.
Oh, okay. Yeah.
There's a Bodo warning. You'll get data.
Okay, so people are already in the next line, so I'll keep going. If no one stops me, I'll keep going. So, as we said, Odo has these URI strings to be able to point to a specific type of database or backend. And the URI types that it uses, it has like the protocol, then, this is like protocol, path to resource, and path within resource. And so for a more specific example, one can be like protocol is going to be Postgres SQL or SQLite, MongoDB, SSH, HDFS, Hive, whatever. Path to resource is going to be the database, and the path within resource is going to be a table, for example. So this is the same URI format that also Blaze core uses. So we're going to see that afterwards. So just become familiar with how Odo uses these URI strings to call to specific data sets in different databases. So here I have a lot of examples. So this is all valid Odo URIs, .json, Postgres SQL, host name, and then table name, MongoDB host name, database collection, and SSH, user host, path to the file, CSV, same for HDFS. So let's have another, well, this exercise is already done, but just so you see how you can migrate the CSV file into an SQL database, and SQLite in this case, and we're just going to create a DB that's going to call myDB and the table iris. And you see that the type of this output is in fact an SQL Alchemy table. And if you're going to if you take a look at your, if you do ls, and you're going to see that my database is created in your file system. So let's just like have like a 2 cents of how Odo works. And this is like a very like hard. You can zoom in and zoom out in the Odo docs in this link here, so you can actually see something out of it, because it's grown so much that it's hard to like realize. But Odo is just like a really vast network of pairwise conversions between formats. And so when you want to migrate into 2 formats, you traverse this graph into like the most optimal way. And so there's like a lot of different connections, because a lot of these different systems already have import mechanisms, and so Odo can like have a cost of each of the edges and see what is the best edge to traverse the graph with. And so in this graph that we've seen, each node represents a data format, and each edge is like the function that transforms from one to the other one. And these different edges have like a cost, and so you can like just with a simple network find like the shortest path between them. And as we see, we could like do a lot of like, you can go through a lot of routes. Like if you have a data frame, go to an NumPy array, a Python iterator, and then to Mongo. But then maybe Mongo just have a read CSV that has a shorter cost than that one. So just use that, and that Odo is able to do that. So another of the sections we saw that the two main advantages was using different databases and also interacting with remote data. To use this, you need to install Bodo. As we've seen, Odo is just this graph and this cost of graph. But the actual transformations happen within those libraries that are actually that Odo imports. So Odo does not do any of the work. It's actually those libraries. That's why if you're going to use remote data, you're going to have to install Bodo. And just Blaze just knows, Odo just knows to find the right path and call these different libraries to do those transformations for you. You can also find more information about Odo on AWS on this link. So just like a simple example, someone already mentioned this, but when you run this cell, you have to run it like, you can run it once, but you get a warning, run it twice, and that's fine. It's a Bodo warning, but just like it says something about network. So you see, like you have this tip CSV that was also mentioned in the previous tutorial in the main room, and you want to get a pandas data frame. So you just do Odo, you use the URI string and pandas data frame. Okay, you can play around and like see how you can also from that URI or from that create an SQLite table or play around a little bit with it, maybe for 2 minutes, and you can like explore and break the code and then open an issue if you break it. Anyone has another question? Yeah. Okay. Okay, so the question is how does Odo transform from one format to the other one? So as I said, Odo is like this graph and knows of like the types of the knows the format of the target and the source, and then has this graph, this network graph, right? And each of the edges has a cost, right? And so we can find, but each of those transformations happens in a specific package, right? Like if it's hard to see, but if you try and go, so for example, pandas has a read CSV file, right? So maybe the optimal edge to transverse from going to a CSV to a pandas data frame is just using that read CSV, right? But maybe there's another path that's faster, right? That maybe I don't know. This is like going to be a crazy example, but maybe if you put it like in an SQL database and then use read SQL from pandas, that was like less. You know, there's all types of different routes you could take. You're just trying to find the one that has like minimal cost.
You have some sort of table or registry in Odo to track what all those
Yeah, I think right now Eric's like an expert, an Odo expert. Yeah, so he can like give more of like the architecture details if. Yeah. Okay. Cool. So if we've seen Auto, now let's go and take a look at Blaze core and learn a little bit more about it. So as I said, Blaze, this core Blaze is a syntax to query different types of databases and different format types. It's pretty similar to pandas. It has some slightly differences, but it kind of has the aim of providing a simple and generic interface, because it has to generalize for all these different types of backends. So maybe something very specific that pandas can do, but it's not very generalized. Then maybe you're gonna have you might have a loss. But we just compare pandas with Blaze. We have this simple example. So if I have a CSV, I can read CSV with pandas, see the first 5 rows, and then to get unique types of species. In this case, I can use either unique, or there's also people that use drop duplicates and just and you can get this list of the different types of species that you have in the iris dataset. In Blaze uses uses distinct, kind of similar with more of SQL databases, and that's as one of the slide examples. A very cool thing about Blaze is remember that string URIs that we were talking about Auto? That's the URI you can pass here in Blaze data, and that's how it imports data from that format. And with that data, you can perform any of the Blaze queries to it. And for example, these species distinct, this same query would be valid even if my data came from an SQL table. So that's a very powerful feature of Blaze, of being able to I don't have to change all my queries if I change a backend, which can be sometimes painful, right? If someone just you used to have SQLite or and then someone just suddenly throws it to a Mongo database or Spark, whatever, and you want to reuse all the code you had. Blaze helps you with that. So as we said, there's a distinction between what Blaze does and what pandas could do. Pandas also has this read SQL, right? So there's an example. Let me see where. Yeah. Just so we kind of clarify this distinction between Blaze and pandas, we see that what pandas does when it reads from an SQL database, it actually imports all the data into pandas, and that's those computations in pandas. So if your actual table that you're importing to pandas does not fit in memory, that operation is kind of pointless, right? So you're always going to have to import things that actually fit in memory, because that's the transformation that it's doing, and then pandas does the computation. What Blaze does is something different. Blaze is able to translate this Blaze query syntax into all these different types of backends. So what actually is doing is just sending the query to SQL, making the translation, but the computation is not done by Blaze. It's done by that backend. So if we take a look, if we have this query here, this Blaze query with this Blaze syntax that's give me the species and the sepal length of an iris data set that has species versicolor. So if we print this, it's just making the translation to a SQL query. The same for let's compute the longest petal length, the minimal petal length for each of the different species, grouped by different species. That's the same. It's a translation to SQL. And then you can say, okay, now I want this query in this type of format using Auto, and you can combine both and say, okay, now I have this. I want the result of this query into a list or a data frame or something else or a CSV file, right? I think I skipped something around here. So this was another example, right? Like, it's the same. Blaze talks to SQL Alchemy, makes the translation, SQL Alchemy, then writes the SQL query to it and computes it in the database is where the computation is happening. So in this example, we can see like, again, we use just this URI with SQLite, the same way we were using for CSV, and we have this database. And in this database, I want this particular table, and I can just do database iris. From this table, I want this column, species, and I want the distinct values. And that's like just the query that I get. And another example, from this database, this table iris, I just want the species versicolor and give me these two columns, species and sepal length. So now we're going to have an exercise so you can play around a little bit with these types of queries and explore. And you have this SQLite baseball statistics database that has a bunch of tables. And there's another nice feature that you're not just like loading a table. You can load actually like look at the entire database and look at all the tables that are there. With data shape, you can see, okay, I have this all-star pool table with all these columns, and it also guesses what the types are of your columns with the discover method. You can see all of that. And then I have a thing at the end. I have 5 exercises. So just try and reply to them. I'll give you like maybe 5-10 minutes. Any questions? Yeah. So the yes. Yeah, that's also, yeah, exactly. So the result, the question was that if you would recommend also writing to using Odo to write to a data source, not just reading from it, and the answer is yes, because then you can control, like using Blaze and Odo together, then you can control what's the desired format where you want, and you can have some of sense, like if you're really like grouping by and you know like that size, it's going to compress a lot. You might just like want to use it in a pandas data frame because then you want to join it with with something else. And Odo already provides like saving those results right in data frames or, yeah. So the answer would be yes. Okay, I'm not hearing anyone typing, and there's like 5 exercises. You can talk to your neighbor if you want to. Hey, how are you doing that query? You're having a problem with SQLite? Okay. Have you like downloaded the file?
When I write, when I do Boto to that, the file is actually created on disk. It's really small, doesn't actually have any data. It has only the schema information.
Oh, but can you?
So if I try to read it back,
Yeah.
Have headers but no data. It's either maybe SQLite. I just updated SQL Alchemy. Probably SQLite doesn't like something.
Okay. I'll try and see what's the version that I'm using SQL.
Yep, because what's happening there is that that's converting it to a string,
don't have like dependencies on SQLite, SQL Alchemy. So, so I'm using this version 3.8. Oh. And SQL Alchemy 101.
The idea is the lazy expression. You don't want to. You don't want to evaluate it since I need it. So the string is actually the representation. The reason I did reference things.
I can take a look after the tutorial.
Yeah,
Anyone has solved all the questions? Yeah? Anyone else? Any other questions or when trying to solve these problems, these exercises? You can also ask yourself a question about the data set and just try to answer using the Blaze syntax and saying if you're using it correctly or not, or if it feels intuitive to you. Okay, the solutions are on a notebook called Solutions, but try it first. That's how you learn. Okay, everyone has tried it, failed, tried it again, succeeded. Just gonna show some of the results. So as we said, the URI can refer to a database, but also a table using the URI syntax. So I can actually just say data, and say this database SQLite, and just with this notation mention the table, and I call the table T, and then I can do T data shape, and then I can see what's in this table, and I can see what all the different columns are and what their guest types are. Then something that you might you probably have to be careful with is this. The output of Blaze in the notebook tries to be interactive, so it just does the compute 10, and if you actually want the full result, you need to call compute for everything. And this is just so it has this very interactive feel, and you can just explore very fast without having to actually compute very large, doing very large computations and then realizing oh, that was not what I meant. Right, and that makes it very fast because you just use it just gives you the output of the first 10. And so if you do team ID, this thing, don't get confused. There's not just 10 teams. There's more than 10. And a way of getting that is that okay, now I want this thing into a list or into a panel data frame, whatever, and then you actually get all the full list of teams. If I take a look of what actually Blaze is doing. I can just print the query, say this is the query I'm looking for, and then I just getting the distinct team IDs. Then a simple question, what's the minimum and maximum year ID of the salaries table? then I can just do this column and get the minimal, this column get the max. Yeah. No, there are no stupid questions. So can you repeat the question? Yeah. Oh. Yeah. 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 So there's the next exercise set for the Oakland team. Pick out the player. These like 3 columns, and you can just like you do with this syntax, say equals to oak, and then like this selecting the columns. Yeah. With a what? Oh, then you can actually do the select with brackets, and like it supports both syntax. You can do yeah. So in those cases, you would just like use brackets and use the string. Yeah, that's a good question. Any other questions? Yeah. How this? Oh, just want to print out more of the head of the data set. So you could transform it to like a pandas data frame and get like the full, or get like a full list, or whatever. Yes. So then, for example, let's say I want to save these results to a CSV. Just use auto and like store your results, and you'll see that you do it less. The result is stored here. Now it's also, these oaks you can sort by salary, ascending, false, and then you'll see what's the what year employer had the top salary. There's also these computations, the group by, which is usually a very common computation that you do group by like a categorical variable and get like the sum of their statistics, like the minimum of a certain column, like let's say species, what's the minimal petal length of the different species. And again, with pandas, you do it with this group by, as you've seen. Blaze has a slightly different syntax. Instead of calling group by, just call by. And you can say Blaze by, what's the column that you want to group by, species, and what are the different computations or results that you want to output. I don't know if I run that one. Then you want to, from this query, like we've seen here, you want to save the result into a list, and we can see that they have species, that's petal length, and then one is the largest, and the other one's the minimum. Yeah. So when you do the query, the first query, it just like, it's not computing anything. It's just like translating that computation in like the specific backend that you're using. But then when you call to specific transformation, like auto query list, that's when it's going to actually run the computation. Then it's when you're going to have to wait for the billion row thing to like finish. Yeah, yeah, exactly. So that way you can like have like different a computation graph, right? And it's not until the end that you actually have the cost of waiting for it. Yeah. Yeah. Let me see. Oh, I think this one. Yeah, and then there was like a final exercise of storing this result into several different storage mechanisms. And if you can, can try that, try running this. And if you have any other questions, you can let me know. Yeah. Okay, so the question was, how does the functionality of Odor compare to like functionality that's already in systems like Pandas? So I would say that it has more connections than what just Pandas does. Like Pandas is all going to worry about loading into data frames and out of data frames, right? And kind of Blaze tries to generalize that to other types of systems. So things that might not, like connections that might not happen through a data frame can occur through Odor. Then it also provides like general interface, so you don't have to learn, oh, Pandas read CSV, Pandas read SQL, or all these different syntax. It's just one syntax, which is Odor from the target to where you want to like put it, right? So it's just like one symbol for everything. And I would say that's also a plus in terms of usability. Yeah. Yeah. So there's some you can see more. Let me see if there are more operations supported that we don't have time to see today, and I would like go to the. I have the. Here's the Blaze. Let me see where that's. There's all like they also have all the different expressions and the API. So here's the join expression for tables. And I think there's an example here. And this one's focusing more on like the expression graph rather than the data API. So Blaze is more complex than what I have time to explain like in an hour in a tutorial, right? But I'm providing like this general interface data API, but actually Blaze is composed of different methods inside of it, and this data construct that we've used is just like a general abstraction, so you don't have to worry about how you create the expression graph, how you call compute, how you call all these resources. Actually, Blaze can provide that for you. Provides like that distinguish of what kind of computation and what's the expression of that computation. That's what's called this types of symbols and expressions. And then you have the when you call compute them and for a specific type of backend. I think I forgot your original question. Yeah. Yeah. So I don't know, like for the different types, like what's how it's gonna do it, but yeah, that's a good question, but I don't know, like for each of the different types, it's gonna do something different, right? It's like different, like if you want to join a CSV with an SQL database, then if you just want to join two Pandas data frames, then probably just going to use the Pandas join functionality. Okay. Any other questions before I pass it to Andy and the Bokeh section of the tutorial? Okay, so we're going to have like a 5-minute break between like Andy sets up and I like go. If you have any other questions at the end of the tutorial, you can just, I'm going to be around and Andy's going to be around all weekend, so you can just ping me. Thank you.
We found, I guess, a lot of people having trouble with Jupyter. It's spelled Jupyter, but I think pronounced Jupyter. So if you haven't used the Conda environment, these commands here, this commands will actually install Jupyter for you. But I think some people are having collisions with other IPython programs on their computer. Sorry about that. We didn't anticipate that. And also, if you're having Windows problems, go grab the guy in the red shirt over there. He loves Windows. He's shy. You go grab him. He'll do it. It's okay. I know his boss. One of the coolest things about Jupyter is they actually have like a whole bunch of different kernels and things now. But what we're going to do mainly is stick with this section 2, Bokeh. And I'm going to go through Bokeh a little bit just to give you kind of a primer. And the idea here was to do data applications. So after we kind of go through kind of a primer of how you create a Bokeh app and whatnot, we'll go through these embedded apps. And I have 3 different ways to kind of play with embedded apps, and then the baseball stats one there. So, okay, so going on to section 2. Can everybody read this guy? Is that pretty good? Yep. Okay, cool. So Bokeh is I mixed it up a little bit. So we're going to learn a little bit about some very basic plotting, and then it lets you kind of just see the elements of plotting that Bokeh gives you. And then after that, you'll see some like their high-level charts interface. Well, I don't go too much into that. It's kind of pretty self-explanatory if you read the examples. And then I'll show some like building an example out of this baseball database and whatnot, and kind of like what we do often at Continuum. So first, like Bokeh's first-class visualization library for web-aware applications without requiring kind of web programming skills. And so if it's the case that you want to share visualizations on the web, you want interactive web style interactions, and you don't want to have to go learn D3 or start writing in JavaScript, Bokeh is there to help mitigate those things. And so that's kind of the gist of it. So take the rich ecosystem that Python already has and use and then generate out to JavaScript. So there actually is 2 components. There's a JavaScript library called Bokeh.js that what Bokeh will do is generate a file that uses that library. And so if you are a JavaScript developer, you could just use Bokeh.js. But I think the more standard usage is to use the Python interface. There's also an R interface and a Scala interface. And so we're adding more interfaces from different languages. I think if you look at the gallery, you click on the gallery, there's a lot of different plots in here, a lot of different ideas how to do things. There's even some, for example, some animated, some like stock examples and some things that show streaming plots coming through and whatnot. It's not exactly what we're going to be talking about today. This guy is not helping. There we go. So there's galleries, tutorials, documentation, repo. It's all open source and able to use. So let's just start out with a little bit. So first off, let's import pandas and NumPy. And so just to give us some examples to run with, we'll use Blaze here in a bit after we go through a little introduction to play around with the different data formats. So first off, the output. So Bokeh, since it's using JavaScript, it can output to an HTML file. But if we want to actually use it in the notebook interactively, it's got to make the import things in the notebook correctly. And so for this, we have to call this function here. It's telling me it's already loaded, but just from Bokeh plotting, import output notebook, and then call the output notebook. As you will see in the other embedded examples, there are other, like there's output HTML, there's output file, and other things that you'll see as well. So we kind of, just like in matplotlib, you have to say what backend you're using. here we're going to say, hey, how are we outputting this, this file out? So let's start here with just a very simple thing. So first I would import NumPy again, because it never hurts, right? But then I say import, take from 102, a sample of 102 points between 0 and 4 pi. That's what this linspace is doing. And then I ask, give me an array of the sine function, and an array of the cosine function on those points. And so very simply, with Bokeh, we say, all right, create a figure. That's a way so that we have something to start plotting into. Plot a scatter plot with that, my x value is that linear array, that y value my sine function, with a web color, for example. And then I could do the same thing here, and you say green. So there's a lot of color support and a lot of support for different things there. And then I just call show, and you should get something like this. So this plot is, the first thing about it is it's interactive by default. You can click on it, and let me turn on my handy dandy click thing here so you guys can see what I'm clicking. Yeah. Yeah, that's not what I wanted. Keystrokes, that's what I wanted. So you guys, so you see it, you can click here and hold it and be around. You can scroll in and out. So if you have data, you can scroll and play around with it. There's like resizing, for example. If you're making a web page and you want to like show a bunch of plots, so if you had like 3 plots, you could kind of arrange them. And there's a zoom, there's a box zoom as well. If I select that one, I can select a section to zoom in on. And always I can try to save it. It'll give me a PNG to save. I can reset it to get me back to my first one. And I can have a question mark to, takes me to helpful documents, hopefully. Helpful documentation. So that's just the very straight up kind of like plotting something. So everybody is able to plot something? Anybody not able to plot anything? Anybody, raise your hand if you're not able to plot. Raise your hand if you don't want to tell me you're not able to plot. Nice. All right, cool. I've taken notes. I will come back to you. All right, so let's play with just like a little bit of like colors and whatnot. So here I colored it red. And so pick your favorite color, change your color, see what works. See if we know web colors work. You can throw in RGB values, so there's black. So very kind of nice to kind of play around with the scatter plots. So here's this next one to play around with. I changed the marker to square. You can see now I have little squares in there. Still just using a scatter plot. And maybe I can change that to triangles. And see, you get triangles. See, I don't know if there's any other cool ones I can think of off the top of my head. So that's, once again, just a cosine plot. Play with those things. So there's tons of other glyph types. So if you look here, you see like annular wedge, annulus. And so, for example, here's an annulus. There's an arc. And so one thing that kind of pops up is the same sort of thing here, or an annulus that gives me the x, y, and then I have inner and outer radius, for example. And so you can play around with a lot of different ones of these. So if I, for example, take this piece of code here, oop, and I add a frame, and I don't need output file. I can see I can have an annulus in the same sort of way. So take a minute, find your favorite glyph type, and plot your favorite glyph type. I guess if you want a very concrete task, there is if you want like a bar graph, there's a rect down here. It's called. So there's rect and there's quad. So a rect is centered and the quad is not. So you might play with rect and quad. No, not that quad. This quad. So, Then you get top, bottom, left, right. I'll give you guys 1 minute while I play with this as well. So here's an example for those who are playing around. Resize it to make it bigger. So I want to do the same thing with a bar chart. I use this quad function just like the scatter. I use my sine array as the tops. I set this bottom to 0. So now instead of setting it as a vector of things, I set it as one value, and it'll interpret that as a vector of things. And then I take my linear array as my left, so that's the y value or the x values. But I need to give some length to that quad, so I just played around 0.1. I can play around 0.2, see it get bigger. If I said something too big, it would kind of get blocky and things like that. So, cool. Yep. Yeah, we'll talk about that when we get to the interactivity section. So, but yeah, it's not, some are included in Bokeh, but you can also embed it in another thing that has forms is the answer, and we'll show you how to do that. Cool. So the next kind of lesson is everything is vectorized. So as you start doing statistic plots, you often want to use different like size attributes or color or something else to show another side of your data. And so for example here, I'll take that linear array and a sine array, once again my very simple scatter plot. And I'll make the size based upon this cosine array. So I'm squaring it. You want to know why I'm squaring it? I'm going to take a guess. Get rid of the negatives. That's right. Because if you have a negative size in web, that's not going to work. And then I multiply it by 10 because I want it in pixels. So 0 to 1. So the squaring will still get me 0 to 1, but multiplying it 10 will get me from 0 to 10. And you can see here how now I have a plot that's both scaling the size based upon the cosine plot. Okay. Turns out you can do this with a lot of other features. So for example, if you want to do the same thing with colors, so here I import Brewer. So Brewer is a web color package, and so it comes with Bokeh naturally. And so if you look here and I say like Brewer palettes, it comes in as a dictionary. You can see the different palettes it has, which come from the Brewer library. Then I pick a palette, for example, I pick my palette and it gives me the grays, and it says, all right, I have grays with 3 colors, 4 colors, 5 colors, all the way up to 9 colors. Okay. So what I'll do here is my palette, I want to take the color with 9 colors, but what I actually want is I don't want it to go from the first color, the 9th color to the first color again. So I make a list of those 9 colors, and then I reverse them and add them together. So now I have a list that goes from 0 to 9, and then 9 to 0. Well, 0 to 8, 8 to 0. Off by 1 error, sir. Plenty. And so I take that, so now that's my palette, so I can go up and down. And then I say, all right, my colors on my palette, and this is just a little bit of math. I know it's after lunch. It's hard. There's a little bit of math to say, all right, give me a palette of all those of that color and map a color to every point in my lin array. And so what this does now is I take the same idea and I say fill color, and I take this array of colors. So if I execute that code, and I said colors, where's it going? I turned on line numbers. I didn't know how I could do that. So you can just see I have just an array of colors. So go to that guy. Okay. So I actually made the size a little bit bigger just so that 0 was not just completely gone. Cool. So everything can be vectorized. I think there's a lot of other attributes on this guy. Let's see here. These are kind of the typical ones. I want to change my color, the size of my marker, and then the different markers and whatnot. So that's different things you can play with. Okay. Any questions about the vectorization side of things? No? Yes? No. So the next kind of like nice element of Bokeh is that it has a lot of tools. But and these tools are basically like things like a hover plot or things that you can point to, pointers and stuff like that. And so like when you saw at the top of this bar, like for example, the box zoom is a tool, the resize is a tool. All these are kind of tools that we have. There are more tools that we show. But the first thing you have to do is you have to create a data source. And so this data source, what it's going to do is it's going to basically wrap around this dictionary and create listeners so that when you change the data source, the tools are notified, hey, something changed. Or the tools can change it as well, and then it can kind of notify it. If you've ever used the Python traits library, it's very similar to that idea. And there's lots of different Python traits libraries out there, so you get to pick your favorite one. So for this example, let's like take a hover tool. So from Bokeh, I say, give me the dot models. I pull in a hover tool. In this case, I pull in an ordered dictionary because the hover tool wants a dictionary because it wants a mapping, but it needs it ordered. So I'll show you in just a minute. The way I can create new tools, so you can actually go through and create a list of tools, or you can do this shorthand where you just have a string of there's short names. And you can see here, for example, I added crosshair, which wasn't part of the default. Pan we've already seen, wheel zoom we've seen, box zoom we've seen, reset, and then I have hover as well, which just gets turned on automatically, and then my preview save. So now I want to create the actual plot here. So I do the same sort of plot creation. You notice I say circle instead of scatter there because we never want one's a way to spell things. So you can say circle instead of scatter. You can't say marker on a color, but it gives you a little bit more of the playing around with things. And then I actually have to do this. This is kind of it's code smell, but you have to go through and say, hey, give me the type of hover tool. So I pull out the hover tool that's actually instantiated on that plot that came from this tools thing. And then this final bit is actually putting what the tooltip is. So I then, whenever I hover over it, I tell it how to what to display. So I display index, and that $ comes from the actual screen space. The @ comes from the source. So I guess I forgot to mention this part here. So you notice here that when I put in things, I say source, and I only give names, or say X is the X name, and Y is the Y name, size is the size name. And that means pull it from the source, okay, just like a mapping. And so here, when I have @X, it's going to pull from that source the X and size. And then this thing is almost, you need it to get the fill color, but they're going to probably change that in the future. But that just gets the color. So now I have, you can see that crosshair tool, and you can see here I have my index, my XY, and my size. So I can kind of play with size. So when you need to debug these things, where is that guy? Really handy. Okay. All right, so that's the hover tool. Any questions about the hover tool? Seems pretty simple. Yes? So you mean like inside the hover tool? No, not yet, I guess. That's maybe a good feature request. Right now, the hover tool itself, because this guy's going to go to Python to JavaScript. I'll show you later, like maybe if I have time, there are ways to get, like for example, there's a tap tool that can tap and they can call a Python function. But in this like little example, there's not a way to do that. So the question was, can I get Python functions in my tooltips as my sort of thing? And you kind of like, there's also a question of like, do you really want a Python function firing off every time you like hover over something? So it's one reason we haven't done it. Cool. So the next kind of feature that I think a lot of people really like is linking two plots. And so this is really nice is when I have lots of data to show, and I want one plot to select based on the other plot, or I want to move things around and find bits and pieces. And so in this example, I do the same sort of thing where I create my XY, and then I create a source again. And this, I show off a little bit, like they say when you teach, you should always teach one thing at a time. And I never believe in listening to people, so I'm going to teach you 3 things at a time. Yeah, it's okay to laugh. So there's the source.add. Instead of giving it a dictionary right off, you can just add things. For example, here I'm just adding columns. Once again, my tools. I have a new tool here, lasso select, but I also have my box select in there. I don't think I had select before. But so first off, I create a figure. I create a scatter plot, and just like before, I use source and I use the names rather than the actual arrays themselves. And then here I say, give me another plot, an S2 plot. And so then when I say I give X range, so normally my X range gets picked off my source. So when I have my given X, it queries that source to pick up what the range is. But here, since I said S1.xRange, it says, all right, I'm going to pick up the range from S1, and now it actually sets up a listener to that guy. So if the X range changes on this plot, it'll change on the second plot as well. And also, since I have the same source, my tools, all my select tools work the same as well. So here you can see now, whenever I move, my X range my ranges change, but my Y range doesn't change. So if I wanted to change that guy, I would have to do something like this: Y range equals S1.range. And so now they're completely linked. You can kind of pick what you want linked. And then, so for example, the box select guy, the box select works. And so now you can see, you can select on one plot and get it updating on the next plot. Okay. And this is all in JavaScript. So if all these functions will go out to a static web page very easily. When we get to interactivity, that's not as true. So, for example, let me see, reset. There's also a lasso select, which I can select kind of lasso. Also, I guess I didn't show this. Grid plot is a nice way to lay things out. So, for example, if I wanted to lay things out horizontally, I could do it like this. So you can have many plots kind of in a grid together. Yep.
Is there a way to avoid that panel web thing all by itself?
Yep. Yep. That's the next section. Just wait. It's coming. All right. Cool. So in the last bit, before we go to how you deploy these into a production environment where you might not want somebody to be running a notebook, there's an interactivity, then I can show you the embedding, and then I'll come back to the last part, which is actually building an interesting app. So basic interactivity. So someone asked earlier, what if I want a Python function to be called based upon these activities? So the first is if you're in a notebook, which is a great way to share analytics, you can actually use the IPython's new widget system. And effectively, all we're going to do, so once again, we're going to create some arrays, signs arrays. We're going to create a simple line plot and say p.line instead of p.scatter. So once again, just using the same sort of idea with my sources. And notice here, you can actually, since my source is, I still have the source column, but since it has this XY, you can get away with just giving it the name, and it actually knows what it's doing there. That's not as reliable, I found, so I tend to use the names when I can. And so now here below, the IPython widget, so in IPython widgets, you give the decorator. So I say a decorator with F is 3 different words, a W from 0 to 100, A from 0 to 10, phi from 0 to 10, and increments of 0.1. And it gives me these nice sliders here. And so this update, all it's going to do is take that F and change the function, for example, sine, cosine, tangent. And it's going to update that source data. So it's going to take Y and then say, hey, I'm going to change Y to be the function that we had. And then it'll say source push the notebook. So this, hey, source, now push out your new data to your viewport on the JavaScript side. And so we execute this guy. We ignore this JavaScript error because I've told Min to fix it. He's on it. And then we do show. And there's like this issue that you can't have. The divs are colliding. We're working with the IPython team to fix some of those. But here we can change the function pretty easily. We can change the magnitude, although you can't really tell because we have auto scaling on. I can change the W, which is my wavelength, and phi, which is my phase. So you imagine kind of from that, like there's a lot of different places you can really explore different types of applications. Let me, since folks are chomping on the bit asking about it, so that's in the notebook, that interactivity. Let me jump over the embedded apps, like the simple embedded apps. So first off is a question of, can I do this in a notebook without a notebook? And so absolutely. So anything I just showed you, if you take that and put it into a script, you can then take this, except for the widget, you can take it and put, instead of output notebook, we say output file. And then I do the same idea. And then when I say show P, what this is going to do is go on the back end, generate that file and the JavaScript necessary, and then launch that file. So I have source, I add the source, I add my tools, I do a scatter plot. Now if I go back, now I will warn you that you don't want to view this JavaScript. It is a lot of JavaScript coming down. It's usually not a problem unless you're running IE 8 or something. Nobody does that, right? No. I gotta do this. But just to show you what it kind of how it kind of works. Thought I had a. There we go. So if I go to embedded apps, go to 0.1 static Python. I just run this code. Py. It produces this web page. You can see I don't have it linked the same way, but it gave me the web page. Goes that web page, and it also gives me the file. And I can take that file and I can put it anywhere because it's one compact file. So that HTML file, you can come in, you can change the code, you can put it anywhere you like. You can send it to your colleague, and it executes right there. It does require network connection because what it's going to do is download. All right, I don't have it here. Because at the very beginning, it actually does download Bokeh. Well, somewhere in here, it downloads off our CDN, bokeh.js, somewhere. But you can put that somewhere as well. And so there's ways to get, if you don't want it to ever go to the network, you can put bokeh.js close to it and play around with it. So that's very simple, static file. I'm not having interactivity. That's often not what people really want. So the next kind of way to do this is the Bokeh server. And so Bokeh server is going to be a web server that's running, I think it's Redis, unless you're on Windows, and then it backpedals to something else. And so here we run this script by saying Bokeh server -- script, and I'll go through the code in just a sec. Let me show you what it does. It's going to launch a server and paste. Yep. So that one, like when it's a small bit of data like that, there's no like it will include it. Like if you look at that, if you go look at your file, you will find a big block of data in there. So yeah, you don't want to do static things with very large data sources. But you know, if you got like 1,000 points, it's not a problem. But yeah. So I run this guy, and then it tells me to go to this one is more fun because it has. You can let me. Oh, I did it. That's what's going on. So this guy tells me to go to this thing here, and I'll show you. In your app, you can put different endpoints on, and so here we have the same idea. So what it's doing here is it's created from inside Bokeh itself, the server. That thing's not going away. There we go. So foo bar, and you can see the same sort of idea. So you can get that toolbar interactivity from Bokeh, just Bokeh itself. Now what this does mean, so I come back and I look at my localhost, you can see it has a Tornado web server, and it probably has Redis running as well for the data. So that's interacting with the data on the back end, but it also has a web server running. So you might not want that, for example, but we have another way to, let's take questions. Yeah. Okay, so in a multi-user environment, what gets spun up? So this basically so since Python here is running, it's just running Python. So if you as a user on a Linux machine ran this, you would if everybody in the room was on one computer, we'd all spin up our own Tornado web apps. If you want to go to something if you want to run it in production, then you could certainly put it under supervisor and then run it as root. Like that, and we do that quite a bit. In fact, the next kind of thing I do, I'll show you how to embed into Flask, which is kind of another way, which is often how I run it, so that it can scale and use better web servers like Gunicorn and Nginx and things like that. But next question. Yeah. Yep. Right, to a CDN to download. So the question is, what was the static page was completely self-contained except for a link, and that link was to a JavaScript library download. So.
The next phase was once I have that static page, so
yeah.
it events the data and have JavaScript, but there's no interactivity. I can't be able to use any of the.
So you can do the interactivity inside the window. So the question is, on the static, what's the interactivity level? So the tools and the panning around the window is available, but for example, this is not available, where I'm changing my data. I can't change my data. So there's like on a static page, you can do things like this and play around and look at the viewport, but you can't change your data. But like this is actually fundamentally changing the data.
So in that case, the data in this case with the server, can that be remote?
So the question is, can the data be remote? The answer is yes, but that's beyond the scope of this tutorial. Yeah. That's the question. So the question is, how do I handle multi-tenancy where I have different people coming in with their own sessions? And I say I let the web framework handle that. So Gunnycorn will handle sessions for you, and so you can come in and it'll create its own session, and then from that it'll interoperate with that session. So Bokeh itself isn't handling that, but you can embed it into a web app that can handle that, which is the next kind of embedding that I'll show you. Any other questions about this? Okay.
Can you put arbitrary HTML along with that other stuff?
Not using the Bokeh server, right? Well, you can, but it's beyond the scope of the tutorial. But let me show you the next one, which is more like what you're asking for. So the next one is Flask. So how many people know what Flask is? Okay, so most people know what Flask is. Flask is a micro web server. And so what I do is import Flask. And so Flask has an app notion here. And you notice here I have this code. Looks exactly like the Bokeh code. I create my plot, and I return my plot object. And the Flask app gives me a route. I say app.route, and it's going to call this function whenever I hit that endpoint. And see here what it does is, so I create my plot in that app, and then I return. So I ask Bokeh, hey, actually generate me my JavaScript, my CSS, and all that stuff, and let me pull it down raw, and I'm going to inline in a file. And then whenever I return and then I ask for the script and div of the plot. So the plot says, hey, give me the components of this guy. I want the script, and I want the div that's going to create that guy. And then whenever I go to create the render of the template, I use a template. I give off the script, the div, and all those resources I just gave. And in this case, I give color, which is going to come from a form. So that color came from the form up here, 44. And then I return. I use the encode UTF function there, and I return the HTML, because just like a web app. So this guy works just like a WSGI standard web app. So now you can embed it in Nginx and Gunnycorn and anything that can do dynamic Python web apps. And you say app.run, and I have debug on here so we can play with it. So in this example, so let me kill the other plot server. Oop. 03. So if you look at the templates, all I have is an embed file here. And all this guy is a very simple web page, so you can embed everything in the web page as you like. And then I have, in my head, I put my resources and my script. And I can put whatever I want as far as for example, I have a form here, and I could embed it into a web page, a much bigger web page. And then I give, and here's where my actual plot goes. It's just that plot div right there, and then I demonstrate. So it's just a web page with all the template stuff coming in to generate the plot. So now if I go Python, spell Python correctly, Flask, plot, and oh, that's the wrong one. I forget on this. So I go to 5,000, and so I get that familiar guy here. Once again, it's have things linked up. And here's the web form. So this is actually going to come to the so when I interact here, I'm not going to the web server at all. That's all JavaScript. But for example, if I had a form, I say submit, that's when it actually goes back to and generates a new plot. And so here you could add a lot of different sliders. I've had a lot of, like for example, I put jQuery a lot, jQuery sliders and things like that a lot. And so this way, it's very easy to embed into a much larger application. Very often. It's a question. So the question is, I'm embedding in Flask. How do I embed in Django? So it's exactly the same process. So and the reason I showed Flask is because it's just so much simple. The code is so much simpler. But so in Django, instead of this app.route, this would just be one of your views. And so your view function would do exactly the same thing. And in fact, when I return here, I'm actually returning the same Jinja templating engine, so you can embed it in Django as well. There was recently a talk at PyCon that was just about embedding in Django. So if you go to the last PyCon, look up Sarah Bird Bokeh talk, and she goes through like a lot of doing stuff like that in Django. So, I'm sorry? Oh, where's the example in my code? So if you go to the home, so from here there's embedded apps. Click on embedded apps, and so the Flask one is right here, and then templates. Yeah. Okay. So so does that answer some of your questions about embedding and getting into a production environment? I do this quite we kind of went this whiskey route and the very easy Python route, because then you can embed it in any one of these kind of frameworks. The thing I'm not going over here is sometimes you have data coming over live. So for example, if I have a stock ticker, for example, that's querying, then you want to use a different kind of, you need to use the Bokeh server, and you kind of have to talk to the list. But basically what happens is when you do the document app, you have a little bit more code to write to get the app put together, but the actual plot itself is very simple. So there's that update function I had before, and so this update data function could very well be another thing that queries a backend system. Whereas on Flask, you can do that as well, but with one thing that's kind of nice is you can store into the Bokeh server, and it'll just you can just throw data at the Bokeh server. Let me see here. You can have another function that just does this update data, and here's the function example. And so then if somebody's looking at your plot, you have another function just running that. Then that update data will make the plot update as well. So you can control it on the Bokeh server that way. With Flask, that's not as easy to do. I mean, you can do it. Maybe I should write a Flask example of that too. But this update data is often what we do when we want to stream data to viewports. So definitely check this code out. It's a little bit more involved. For example, you set up events in order whenever you click on things so that it checks off the values and so on and so forth. All this is very similar to what the widgets code is doing in IPython Notebook. So so somebody asked an example about, leave this page. Somebody asked if you could get something to call a Python function based upon a tap or things like that. And so here's an example in here called link_tapserver.py. And so this guy's using the Bokeh server as well. And so what it has here as two sources that are going to interact with each other, and it uses this tap tool. Now this tap tool, so you add the tap tool to both of them, and then I have this function on selection change, and so on source one, I can actually add this on change the selected. So this Python function will be called based upon these two things, and so then I can have different buttons, and then so here's the reset button and so on. But to show you kind of how it works live, we go to my handy dandy. So once again, this is the server. And so spell Python correctly. Connection refused. So this one, server, call Bokeh server in the background. And so this is actually where you can actually have Bokeh server running actually someplace completely different. And then I call this guy. And so this is an example, just a very simple example where I can tap on the plot and it turns that guy red over there, for example. I can reset it. I tap on this guy and it changes the size of the other guy. So and that's what that's going to do is when I tap on this, it's going to go back to that onSelect button that's then called inside the Bokeh server and then pushes back to that data source. So that embedding exists as well. Okay, so those are kind of the elements of embedding the apps. Is there any questions on how to embed these apps as I go through all these windows I now have open? Questions? Okay, so there's. Oh, so that one, that error right there. Sorry, I'll add it better. So you had to call. So I have the Bokeh server running. So you have to call Bokeh server first, and you have to call it in the background. Yeah, and then you run the script. That one you actually run as a script. The previous command I had, you can actually give Bokeh server a script to run itself, but often what we'll do is I'll just have a Bokeh server running, and I'll throw plots into it. That's how you kind of throw plots into it. So if you want to create your own plotly, very simply, by throwing plots into the Bokeh server. That's kind of what we do often. Cool. All right, so the last 15 minutes I have, it's not the one I was executing, was it? Okay, let's see here. That's not the one I was, gotta get the live one or else I'm not gonna be, yep, there we go. So let's go down here to the last section. The last section I wanted to kind of show, like, the first hour we talked about Blaze and querying data, and now I've showed you the elements of, like, all right, you can change shapes and sizes and plots and whatnot. And so I want to take you through kind of like building an app based on this baseball statistics. And I have to warn you that I totally blame Matt Rocklin for giving me this idea of using baseball, but I don't know a thing about baseball. That's not the wrong one. So if I say something wrong, just blame Rocklin. That's all I'm going to say. Matt Rocklin's the guy who writes Blaze. For everyone know. So I import everything again. So first thing I say, I load up my data. And so just to kind of look at my data, and often what I'll do is I'll pull up an IPython notebook and explore the data quite a bit before I build this app. And so for this case, I say, all right, what's actually in the Lumen SQL light source? And the first thing I see, oh, there's all-stars. All right, I have some appearances, awards, players, battings. That's always fun. But I think the one I settled on is like, I found salaries back here, and everyone likes to talk about how much baseball players make. So played off with salaries. First thing I do is I check and say, all right, I have this team ID inside there. Let me just get the distinct. And one thing you'll notice here is that the data has some funkiness to it, like this ML4. There's, I guess, like not all these teams exist anymore, and some of them existed at different times. And so there's like Tampa Bay. I don't know. I think that this is actually a cleaned up version of the database because there's one database that has like 150 teams in it or something. And so you can kind of play around to see like what's actually in this thing. So the first thing I want to do is like, well, I want to compute this guy in a data frame, for example, and I get a cleaned up viewpoint of it. But that's exactly the same thing I did before. Here, once again, using Odo, I do a compute, for example, I say distinct, and that gives me the query, and then I throw it into Odo. And so my results now, like for example, I need to I want to see by team, what's their mean, max, and kind of the ratio of their salary. And so here I say I use Blaze by, a group by operator, and I'm going to group by on the team ID. And then I'm going to have 3 computed columns in my group by. I'm going to have the average, which is grouped by mean, because we have to have two names for everything. I have max here, which will give me the max, and I have the ratio of the max over the min. And so in this case, I do a group by, and I say, all right, let's sort the whatever comes out by the ratio and ascending, and I throw it into a pandas data frame. And so now, someone asked earlier about what happens if you have like a really large thing. Often you don't want to actually compute on it, but often you want something like the head. Give me the first 10. So here's like first 5. So Philadelphia and LAN, whatever that is. NYN, I don't know. So that gives you some notion of like there's some pretty high ratios, like 400 times. I wonder if what the tail looks like. Do I get a tail? And so, man, that's really large. But like 39 is a kind of the low end of the ratio. So it's real data. We have things that missing and all that sort of stuff. So I'm not quite sure why this got a nan, but maybe their minimum's a nan. So now the first thing I want to kind of play with this guy, and so that gave me the ratio. But actually, when I wanted to plot it, I wanted to actually see the average, so I get that nice curve. So I say, let me sort by average. And notice I'm using pandas here, just because I can pull everything into memory, and so there's no use since I pulled the chunk I want to use into memory. I was just like, all right, let's play with pandas often, and since that's kind of what I know. And so I throw pandas into the source database. Give an X range of the ID and do a scatter plot. You can see right away there's this beautiful plot, which gives me nice scatters and something I can't read. So the first thing I do, so what I want to do there is like, this is why the notebook's so nice. Is like, all right, so I literally Google how to get that to be nice, and then I find this line here in Stack Overflow. So I say, all right, just give me a nice like NPy divide by 3, and I get a nice little kind of X factor there. And so play around with it, and you can see here LLA has the highest average salary, and I guess this is New York comes up next, and so on. Now, for example, so that's a good kind of nice plot, but I want to add some more interactivity to it because it's not. I mean, that's like just showing plots is no fun. And so let's play around with. Oh, what did I do? There we go. So here, let's play around with the average versus the ratio. And so what I did here, and I changed the width, and then this thing. So since we're on a projector with, it's kind of hard to see. I can get a bit bigger. And so you can see here that the correlation between the average and the ratio is not really there. And I can even play around zooming in, or that's not really what I want to do. Do a select. I can kind of select the top guys there, and they're kind of like all over the place. So that kind of failed. No, nothing to show there. So then I say, well, what about all stars? Maybe there's some correlation between the all stars. And so what I do now, I say, all right, let me go to the all star table. So I have an all star table, group by team again, and all I'm going to do is I'm going to count them. So I'm going to count the all stars and sort by that. Here I use Odo to data frame, and then I pull out another result out of this guy. Not quite sure why I did that. In fact, I don't really have to do that. This is live code. We'll see if this works. So I should be able to just do result to data frame, and then we could pull out my all stars. Oh no, there's something going on. So there's a bug somewhere. So I need an intermediate. Oh, I know what it is. So somebody asked this earlier. So when I just pulled this guy out, I actually pulled it out of a database. But if I want to actually compute something like compute the group bys and the min max, I need something to go to the back end. And so what this guy does is Odo pulls the result, puts it in a data frame, and then Blaze data now Blaze is going to drive the data frame instead of the SQL result. And so then whenever I do this guy, Odo gives me the data frame again, but with the selection, correct selection out of it. And so that gives me, so this is kind of the sort of thing you have to kind of play with, like how do I get this data into this other format so then I can use Python, for example. And so what I wanted from this guy was I wanted the maximum number of all-stars from a single team. And so I get that because I want to normalize my data on that. Because if I don't normalize my data, then the facets aren't going to be very interesting. So then I get a normalized data, and you can see that I have the top one has 1. So the next thing I want to do is actually make, like, for example, I want to use the size. So the same thing before where I just squared the cosine to make everything even, and then added 10. Same thing I'm doing here. It's like, all right, well, let's take this all stars and like show counts by size. And now, so now I have this table, which is, you know, a team. Well, it's an index. I'm just pulling out the all stars, and I have some normalized list of all stars. So now I say, Blaze, join this with my other data frame, which had all my salaries. And so, and I look at this and join on the team ID. And you see now I have my all-star count, which had the normalized guy times 10, the player or added with 10 to get some sizing. And then I have everything else I had before. So now I can take that result, pump it back into a data frame. So now I've got my data kind of figured out, and I sort the guy inside my data frame, and then I give my source. So this is my final piece that, after I did all this work to get everything kind of munged together, which is very common, like I do a lot of data munging, then I can pass off to source, do my scatter plot again, and turn my plots and show this guy, and show that I did not execute everything. And so here we can see, all right, well, there's some interesting things. That at least the guy who pays the most has the biggest circle, so that's at least nice. But that's just 1 year. If you went back up here, I actually only pulled out 2013. So perhaps I want to make it interactive and look at like other years. So I take up everything I just showed you and pull it into one compute data frame. Start with the year 2012. And then I just use Odo to actually pump it. My source, I can just take that function and pump into my data source and do the plot again. And then I play with the same idea with IPython widget. And now I have my widget, and I can change by year. And so now you can see this is a little hard to see on this screen. Let's make it a little bit smaller. You can see here, New York, kind of like something's going on there, that their data is not changing very much. Oh, there it went away. And so you can kind of see, an app you can kind of play with and explore your data. So that's a very common thing we do. And you can kind of, like the correlation is not working too well. Like this guy down at the bottom seems to be very good for how much money they're spending, and so on. If you want to see this guy actually work without the IPython notebook, as I'm sure the gentleman in black would like to know, this code is here in a Flask app. It's the same idea. I have my Flask script. I import all my embedding and whatnot. And then I say, here's my data file. And here's kind of like getting the teams out and whatnot, so I have it as a global. And then I have my create plot, which is actually the same great plot I had before with the same Odo calls and all that, so I return the plot. And here's my Flask code, which is pulling down the teams. Here I'm selecting teams and selecting the year from forms, for example. And then I do the same code. Yep. This here? Yeah, so this here is kind of this is the create plot. So this is you can kind of consider boilerplate. But all it's doing is saying, once again, instead of generating the entire static file, only generate the inline pieces of that file. So, and that's what I'm breaking those pieces up, so that when I pass it off to the template engine, it can generate those pieces in the right spots, right? No, it's it's what you do. It's what a normal web app does. A normal web app, you want your JavaScript in one place, your CSS in another place, your head file in another place, and the script in another place. And so this is just allowing you to do that same thing. And so to show where that actually, so inside the templates, it's again, the exact same template. So for example, those plot resources go here, this plot script goes there. And here, like I have a little bit of form kind of selection, so I can select the teams. Because I wanted to pass back the teams because I don't want teams that don't have data in them. And that's why I'm passing back teams there. Here I pass back what years, so my database can figure out what years I have. And then I have my plot div, and that's where this goes. That's right. So this is the HTML that's going to create the form, and the form will then hit that back to the Flask. So that's what goes into here, this Flask request.
So these are the identifiers inside the render or the identifier that gets embedded in the template.
That's right. That's right. And we just handed the dictionary, and you can see where you handed the dictionary right there. So, and then you can run this guy. It's not completely the same as the app above it. So if I go into 04 baseball stats, Python, so I just run it like a regular Flask app, or embed it into a WSGI container the same way. And so I say, it starts up Flask, and then I go to my other web page. Not that one, because I don't want to throw that away. Oh, yeah, once again, pasting and copying from a terminal in Jupyter is not as easy as it looks. And you see the same idea here. Let me resize these things so they're, once again. Yeah, there we go. There's something. So in here I'm actually showing, I show, I'm not sure what I was doing here, but you can see I can submit and get new plots. Ratio by team, and then there's salary. Oh, so this is actually the salary of the players, so you can see the actual breakdown of the players. So it's a very similar idea. So I can see the ratio of the teams, which you remember was nothing, or was kind of random, but here's the, I can select out which team I want, for example. And so there's Texas. And so yeah, whoever Beltran is, he makes a lot more money than these guys. So awesome. All right, that's our time. Is there? So the question is, are there interactions that don't require complete redraw? Right. Yep. Yeah. So, right there, for example, in Flask, right? So the form, that's going to be a redraw because I'm submitting, and that's a refresh. But all the actions that happen inside that viewport, there's no redraw. So, yeah. Yep. That's what that so when I was showing the server and I had that update notebook, so the question was, can it be updated live? And just earlier when I had the server and I said, update the source, so I can put that source somewhere and I update that source, then that'll actually push it out to the listener. So, yep. Yep. We should probably talk about your specifics that you, like exactly what you want, because, yeah, sometimes it is the case that you want a web server and Bokeh server kind of going back and forth, but not always. So the question was, do you have to have Bokeh server or web server? So Bokeh server can serve pages too, so we can just let it serve pages. But if you're in an environment that's like really taxing, you don't want to do that. You want to have Nginx serving something. So like all these things are possible, but not possible to give you in 1 hour. Yeah. So. So yeah, definitely. And for any more help, just email. Just let us know. Chris, you can get in touch with Christine or I. We're on GitHub. All of our emails are live, are given away because of GitHub. So if you can figure that out, just check the Git history and you'll get our emails. And definitely check out Blaze and Bokeh and submit bugs. They both have user groups. The author of Blaze, or one of the authors of Bokeh, is in the other room, so go grab him. I know Eric's in the room, and he twiddles with Blaze some. And Phil Cloud, who's going to be talking tomorrow, who's a contributor to Pandas and Blaze. So thank you very much.